All right, welcome everyone to the Artemis panel. We have a lot of special guest speakers today, and I'm going to introduce them one by one and let them give a short introduction for themselves too, and then we will go right into questions. So our first panelist is astronaut Tom Marshburn. He was an astronaut on STS-127, Expedition 3435, and coming up on Commercial Crew 3. So welcome, Tom.
Hey, it's great to be here. My name is Tom, and had a chance to fly a couple of times, getting a chance to fly again, but importantly, regarding this discussion, I've had a chance to wear the ACES suit for shuttle, the Sokol suit for the Russians, SpaceX suit for Dragon, and actually wear a pressurized suit in space in the EMU when doing 4 spacewalks.
Great. Okay, next up is Brian Johnson. He's the NASA Exploration EVA lead.
Hey, good afternoon, everybody. Yeah, so well, she just said I'm Associate Deputy for Exploration in the EVA Office. So the EVA Office in general tries to provide, kind of a integration function for what we call our EVA community here at Johnson Space Center, integrating all the folks from the crew you just heard from, safety, operations, and especially engineering, as well as our human health and performance folks. Bring all that together to provide EVA services and capabilities for the various programs. In particular, for myself, I support more the exploration side and interfacing with the Gateway and Human Landing System projects. So that sounds all fun, but just so you folks know, just a few years ago, we were a small technology team trying to pull all this together into a flight system, but here we are. And what I wanted to do is kind of talk a little bit here in a second about exactly where we are with respect to XEMU development for just a couple minutes, I promise. And then we'll leave lots of room for questions. But ultimately, our office is here as kind of a customer for all these ideas that you guys are bringing forward. So pretty excited about this. I wanted to really quickly say that on behalf of Chris Hansen, who's the director of our office, he would love to have been here. He's on leave this week, but he's got 2 kids in college, and he just loves all this interaction at this level and getting your ideas. So he certainly is missing this event. So again, real quick, just wanted to kind of give an overview so folks know where we're at this point. We're marching down this Artemis program path. For us, from a development point of view, that means not just suits, but a lot of integration hardware with the vehicles like Gateway and the various lander concepts out there, as well as tools. And where we are essentially with the XEMU is we're between what we call preliminary design phase and critical design phase, kind of right smack dab in the middle of that at this point. And in our world, what we tend to do during that phase is it's much like what you guys have just been through. We're kind of in that design, build, and test mode. So we are building up something that we consider a very high fidelity, almost flight-like unit of the XEMU at this point. It's in the labs coming together right now. Within the next, we've been slowly doing it at the component level, but we're literally a couple months away from essentially putting together an entire suit at this point and running it through the rigors. So we're getting really excited for that, and that's going to take out a lot of risk for us as we march forward with the suit. But one thing I did want to kind of bring this home to the folks here is that, we've been spending years on all this technology development, a lot of that in-house for the life support system and the pressure garments. Those are things that aren't widely out there in the market. We obviously, or maybe not obviously, haven't spent a ton of finances or resources, if you will, on all these informatics. And there's a couple of reasons for that. One is that there's a huge market out there, and it's moving so much faster. And you guys kind of demonstrating here, and I looked at the posters and they're amazing, that this whole technology area is just moving incredibly fast. And so we're more of the receivers of that technology. When we're ready, We're setting the scars in place for the suit to accept things like, whether it's sensors or cameras or displays, to accept those type of informatic devices and bring them in, and just waiting for them to mature and bring them in at the right time. So just really excited about that. And again, I'll just say the posters were amazing. I'm really impressed with some of the acronyms out there, especially. And but just little facets I noticed throughout it that you guys are considering things like even just down to lighting. I think a couple years ago, nobody even thought about the lighting situation. I noticed several folks looking at that and a real focus on the human in the loop testing. So congrats to everybody, and I'm glad to be here. Thank you.
Okay, next up we have Brian Alpert. He's in the EVA office as HLS EVA Integration Lead.
Yeah, thank you. I'm excited to be here. And yep, my job, Brian Johnson actually hit on a lot of the bigger picture of what my team does with HLF EVA integration. It's that really cool job that interfaces or it's that connection point with all the really cool EVA hardware like suits and tools and vehicle integration hardware, and working with the different HLF partners that we have to make sure that we're going to be supporting their mission and really giving NASA the capabilities to go do those surface spacewalks to the best of our ability with each partner. And so a lot of our work over the last 3 years really started with formulating the whole mission architecture for the human lander, working and evaluating different contractor proposals, and then over the last year or so, really working in a lot more detail with all 3 teams that were selected for the base period of that contract. So it's your SpaceX, Blue Federation, and Dynetics, and really getting to see all these really unique and different lunar lander concepts and architectures, and understanding how our EVA system would work with each of those unique concepts. And so you probably heard the news even just last Friday, NASA announced that they selected SpaceX for that first lunar demonstration mission that includes the crewed lunar landing. So we're really looking forward to that. We're currently still waiting. There's a period of time we have to wait before we actually proceed with all that work. But aside from just that first landing, there's a lot of other work we're looking forward to getting started on as well. And so not just that first lunar landing, but also for all the follow-on missions that come with that. So those will include things like working with commercial payload providers. So you can imagine there's a lot of science and geology equipment that the EVA team is going to have to interface with. Working with lunar terrain vehicles, so like your unpressurized rovers, being able to drive that around, probably bring samples and tools along with you. Living in lunar habitats, right? So not just working on the human lander vehicle that ferries you from the lunar surface and back, but actually working with any lunar surface habitats and living there for a longer time. And then eventually too, pressurized rovers, where you're actually driving around for a couple of weeks and doing more detailed science in between, your stops at a habitat or a human lander vehicle. So there's a lot to learn and a lot to work with. And so as our lunar capabilities continue to mature, the important part of the work that I do with that integration role is making sure we're maximizing the capabilities on the surface or on any mission, right? So we have EVA hardware systems and we have vehicle hardware systems, and the goal is to make all these teams work to give NASA or give everyone here the best product to go do the science, do the research, and go do these exploration spacewalks.
Awesome. Okay. Last but certainly not least on the panel today is Stephanie Sipila. She's the EVA Office Strategic Planning and Communications Manager.
Hi, everybody. I'm really excited to be here. I'm going to start by telling you just a bit about myself. I originate from Troy, Michigan. I have 2 degrees. My first one is in engineering physics from Embry-Riddle, the Daytona campus. Specifically, that is spacecraft design. It was a degree that set me up well to either pursue an academic research career or an engineering career. I chose engineering and came to NASA Johnson right out of school. After a few years, I went back to graduate school and earned my master's degree from the International Space University in Strasbourg, France. Between the 2 degrees, I have done 4 co-op semesters, and I want to tell you that I think the best thing you can do for yourself, for your career, for your future is go try this out. Projects like what you're working on and co-op semesters are just a wonderful way of seeing how you want to fit in the world as you grow up to be a professional, or perhaps continue in academia following the research path. Both are really important for you, and then also really important for NASA. In my current job as the Strategic Planning and Communications Manager, I look for the EVA team to see if we are strategically sized and shaped to serve and meet all of the all of the agency's spacewalking needs. So in today's landscape, we EVA serve the International Space Station, we serve Gateway, we serve Artemis. That of course includes the human lander systems that Brian Alpert was just talking about. And it helps us as an organization make sure we are strategically aligned with the goals of the agency. The second part, and perhaps the more public part of my job, is strategic communications. And this is making sure it's an internal job and it's a public-facing external job. Internally, it's making sure that across our EVA community that's just shy of 2,000 people, that everybody knows what we're doing and why we're doing it. This is often a really challenging task because the world changes so fast, the agency changes so fast, and our teams change and evolve with it, but it sometimes means that the space station supporting EVA team doesn't know what the exploration EVA team is doing. So it makes for some really interesting conversations. On the public side, I get to do outreach. I get to create social media products, and I'm going to shamelessly plug and put into the Q&A our public NASA EVA website. Please follow us. Please get on there and have a look. There's lots of great things we can do. Before we roll into some of the questions that I know Deb has for us, I want to spend just a short second to talk about what is Artemis, just to make sure you guys have framed for you what exploration looks like for the agency and particularly for EVA. You know, Artemis is the return of the agency of human exploration to the moon. We're not going to go back to the equatorial moon the way the Apollo astronauts explored. We're going to go to the South Pole, and that's scientifically interesting in ways that we didn't even know were interesting when the Apollo missions went there. It's because of the 50 years of lunar research that was enabled because of the Apollo missions. Within the Artemis mission family, we have the Gateway, which is the lunar outpost that will be a jumping off place to get astronauts and missions to the surface of the moon and also deeper into the solar system, most likely Mars first. The other really important components of Artemis, of course, are the launch vehicle, the SLS, and Orion. And along with what Brian was talking about with the human landers, we also have a commercial entity and an academic participation that we want to bring with us. When we go to the moon with Artemis, we are going as a global society. This is not NASA going by ourselves. This is all of us, everyone bringing their best to the table and helping us do this type of human exploration, the kind that is just really inspired deep in our souls. So I'm really happy to be here today, and I look forward to your questions.
Hey, Deb, I believe you're on mute.
Sorry, technical difficulties. Let's try that again. All right, so we're going to open up the floor to all of the panelists, and we're going to start with this question. What do you think are the greatest challenges to conducting planetary spacewalk tasks?
I can kick us off, and then my real hope is that everyone else will jump in. How about that? So, you know, the first thing that I think is important when we talk about challenges to planetary spacewalks is at least understanding or acknowledging, you know, where we've been. And you think about the Apollo lunar spacewalks, and you know, the first thing I think of is kind of an astronaut in the A7LB spacesuit that doesn't have a whole lot of mobility around the knees or the ankles or the hips, and they're kind of doing a bunny hop and they're hopping around the moon. And you know, it does look kind of fun, but at the same time, something that I've had to kind of reset in my brain is how dangerous that actually can be, right? Any slip, trip, or fall onto a sharp rock can be really dangerous. You're obviously not walking around in a natural way, so you want to make sure that our astronauts are safe and healthy and effective. And honestly, I think that goal, whether it's 5 years, 10 years, or 30 years from now, the goal is for the spacesuit to protect an astronaut, but not to limit any of the astronaut's mobility, vision, or anything else, right? You kind of want it to be like the astronaut wouldn't even know that spacesuit is there. And I know that, you know, there's a lot of iteration between where we came from in the Apollo days to where we want to get to. But I think one of the greatest challenges to planetary spacewalk is really the suit, at least from the suit side, right? I'm coming from the EVA world, is having a suit that's mobile so the astronaut can do all the tasks that we're asking them to without exerting a ton of extra force. And so anyone that's gone on a hike or been to a national park, or you know, you see geologists work, there aren't many geologists that do science standing fully upright and reaching down and just like looking at rocks on the ground, right? Every geologist I've met is on their knees, they're looking at rocks up close, and we want astronauts, you know, many of whom are geologists and all of whom are trained in the same geological sciences, are able to do that work to the best of their ability. So to me, one of the challenges to conducting spacewalk tasks comes from the suit itself and making sure they can do the work. And the one other thing I'll add before hopefully everyone jumps in and corrects me is, you know, right now when we do spacewalks on the International Space Station, they are highly choreographed. And when we did spacewalks on the Space Shuttle, they were so highly choreographed that I swear the astronauts that were doing those spacewalks knew every step of the procedure as well as I did. And when we get to the moon and we're doing geology, a term that the geologists that have been teaching me more about the science like to use is more of a flexecution, right? So we want to have enough flexibility built into a spacewalk, whether that's an interesting thing that they see in the distance or an interesting finding because of a rock or an experiment, that they have enough flexibility in the timeline to go ahead and really dive into that further. And so there's going to be a lot of important either technological or communication type skills that are built into enabling that flexecution for planetary spacewalks.
Yeah, I'll jump in here too. This is the other Brian. I think he did an awesome job. The only thing, so I'll echo that, yeah, let the astronaut feel like they're a geologist. And I don't know, there's a picture behind me, right, of someone kneeling on the surface there. You know, we couldn't do that on Apollo. It just wasn't viable. And we already knew, I talked about some of the development testing we were doing now. We can do this. We can do this at pressure. It's not a crazy feat. And it just makes being a geologist that much easier. And then Brian got there. Essentially, we're going to push ourselves. Some of the hardest things we're going to do on the surface because we're training for eventually going to Mars, right? So we need that autonomy, and so we could have, 10-to-1 training ratios on the ground and hundreds of ground controllers for every astronaut flying. But that's not our goal. Our goal is to eventually give our explorers autonomy there, and we need to start practicing, if you will, that on the lunar surface and some of the challenges, especially going to the polar regions and the lighting and some of the other conditions. We probably will need that navigation capability, especially going to those polar regions and making sure nobody gets lost, literally. So that's my little speech.
I could add just a couple of words to that. I agree completely with the Bryans. from the user end of it, boy, this is what I'd love to be able to do, and I know astronauts would love to do it. We want to be effective. We want to get as much return on what it cost and the risk of getting to the planetary surface, as much as return on that as we can. Wouldn't it be great if we said, wow, that looks cool out there. I think I'll put on my suit and go outside, and be able to do that in about 15 to 30 minutes or so. Right now, it's quite a long procedure to get out into a spacesuit. It is like a little spacecraft. Check out all the systems, put it all together, do pressure checks, and then go out the hatch. One of the challenges for that is the pressure changes that an individual undergoes when they leave their living quarters to get in their suit and go outside. But we would love to be able to make that transition as easy as possible and minimize the risk that we might get the bends, minimize the risk we might injure our shoulders or our hands. We typically do that with the suits. They are engineering marvels, what we've used so far. But they could fit better, if that's the right word, still allow all the movement that we've been talking about and minimize injuries, so that the next day it'd feel perfectly normal just to go right back out and do it again. You don't need any recovery time. And then the next day and the next day. That would be our hope and our dream.
And I'll chime in here too. I think one of the greatest challenges is the things we don't know, right? We already know there are things we don't know how to do, and we the NASA EVA team, publish that list annually, and we put it out in our public reference space and say, hey, world, if you want to do something that's going to be interesting to NASA and EVA, please work on these problems that we already know we have. And what I like really so much about the suits program is that you guys are thinking even further than that, right? You're thinking about how to take cutting edge technologies and make them relevant to EVA. So to me, the biggest challenge is the things we don't even know we don't know yet. And that takes creative, innovative minds to help solve.
Awesome. Okay. So an add-on to that question, how do you see future technology providing solutions to some of these challenges that we've talked about?
I'll lead there, and hopefully I'll do the opposite. Maybe folks can help me out. So right off the bat, the whole suits project there is an amazing technology that helps us kind of, in some ways, the real-time aspects of that, making the overhead of the astronaut easier so they can accomplish the tasks in the time frame they want. But so that's absolutely vital, and gives all that and kind of front-end user capability to make the EVA as efficient and safe as possible. So that's one definite technology we need. And in front of that is just simple. I wouldn't call it simple, but programs, things to allow astronauts to plan their own EVAs, for example. Brian, we invented this term here locally, flexecution, but giving the astronauts the skills they go out and find a few sites. We call them, grade those sites to just opportunities. We send that information back to the scientists. They say, hey, go after 2 of these 3 sites. Those have the best probability for some good science. And we go out there, and the astronauts can then plan their next EVA, and you're not doing EVA after EVA that's been planned months in advance. You're allowing them to chase the science and let the science kind of motivate things as well. Trying to think of other technologies. I'm probably having a brain freeze at this point. So I'll let anybody else jump in.
Yeah, I'll piggyback right off of that, Brian. And one of the first things about technology that can improve the autonomy of astronauts that came to my mind is something I do down here on Earth. I like to work on my own car rather than taking it into the shop all the time, as long as it's something I can handle. And at the end of the day, right, I don't typically, my first step in trying to figure out what I want to fix, whether it's a spark plug or something on a tire or whatever, isn't to go to like my auto manual book, right? What if the first thing I'm going to do is I'm going to grab my phone, I'm going to go to YouTube, and I'm going to be sitting under the hood of the car with the YouTube video going back and forth to make sure I'm doing the right thing. And so, you know, I do see at least some kind of similarities to how we can help astronauts be successful, you know, on the moon. If they are going after a certain type of geological feature, or they're going to work on a very specific payload, you know, maybe there's that just-in-time technology that's available where, hey, I'm going to pull up this quick video to remind myself of the training I got a year ago or 3 months ago or whatnot. And that's going to be a really good refresher as I go into the step. And yes, you know, mission control is going to be following along through my helmet camera and things like that. But it's a really nice way to have some kind of on-demand information as I'm getting ready to do the task. And again, YouTube, the fact that it's something visual, you know, I'm a visual learner, definitely helps, you know, sometimes seeing things that way as opposed to just reading through a procedure or having a procedure read to me from someone on the ground.
I think that big data plays into this too. It's a very hot topic in the IT world, right? Big data management and big data integration. So what I envision is somehow merging the big data integration project with voice activated personal assistants, right? You clap on your lights, you call to whatever personal assistant runs your house, and you ask them to lock the front door or start the water boiling on the stove so you can cook dinner, right? And it's the spacewalking version of that I think is going to be really telling for us.
Those are all great comments, Stephanie. I love your what you brought up there too. So imagine, as your panelists, I think in large part have had a chance to do this, and I certainly have. Imagine putting on the helmet, putting on the spacesuit, and you know, you can't scratch your nose, you can't reach your face. You might have a touchpad on a wrist, but voice activation would be nice. But also your helmet is filled with stuff. You have a little comm mic, perhaps. You have some diagnostic hardware. You might need to have something so you can squeeze your nose to clear your ears. You have a drink bag, maybe a food bag. So it's pretty cluttered in there, and it gets pretty hot and humid and sweaty. So if you have eyewear, that might fog up and might fall off. So there are a lot of things to consider as we think about putting all this in the spacesuit, all of which would be desirable, but also it wouldn't be like sitting at your desk and having screens around you. And in terms of the just-in-time training for at Mars, we couldn't be real time. So the big data, the ability to cache information so that we could call it up and get an immediate response would be important as well as we move away from the moon.
Okay, so what non-EVA related activities do you see augmented reality being beneficial to astronauts? For example, like medical or maintenance or anything else?
Well, I'll jump in because I think, oh, go ahead, Tom.
Oh, go ahead. Well, I'll just jump in real quick. My background is medicine, and so we've looked at that quite a bit, particularly taking a group of astronauts who maybe they're all bright and motivated. They may be a test pilot, maybe a geologist, but they might do medical tasks. So getting somewhat complex medical procedures, terminology that means something to someone who didn't go to med school, with hardware that has a high chance of success in its use. So it doesn't require years of skilled training in order to implement, and with that real-time feedback saying, or just-in-time training, probably voice activated because probably your hands are full as you work. That'll be important, as well as the diagnostic capability, putting in information as to what is going on with the human and then having it give you a likelihood. Terrestrial medicine has been looking at a lot of these things. I think what we need in space, particularly as we go out EVA, will, particularly as we want to monitor the human while they're out EVA, that will really benefit medicine on Earth. You have to break down all kinds of barriers that we really can't in medicine on Earth. You know, someone might say, well, you're not certified to do ultrasound, so you can't do that. And yet we found out on the ISS with minimal training, we can get very targeted, specific ultrasounds, get great quality. Not to say we are ultrasonographers at that point, but for what NASA needs in space, we can accomplish that. So those kinds of things are stuff we've been looking at quite a bit.
Yeah, that was awesome. You know, the only thing I can add to that is, you know, in some ways you talk about maintaining the human. It's just then maintaining the myriad of systems as well, including the suit, of course. On top of that, you know, there's only a handful of astronauts that get to go at a time at this point, and it's just, you know, to put on those individuals all the things that we could possibly do, because again, our goal is to go stay and be prepared for anything. These aren't development flights. You know, the first couple will be, but eventually our goal is to be sustaining up there. So we need our astronauts to act like doctors one day and a tech the next day and be able to rip into things. We learned probably the hard way, but it really taught us a lot. The current EMU is not built to be, I'll call it, dug into and maintained, and as Brian was saying, pull out your YouTube and dig into the engine on orbit. Yet we ended up doing that, and we found out the hard way that, you know, it takes a lot. We had to send up lots of procedures and everything, and kind of prove that they're not doctors, and they're not sonographers, as you said, and they're also not supposed to be technicians, but yet at times we do call upon them to do that. And so, you know, it probably took us hundreds of hours and lots of procedures to tell them how to pull a pump, you know, or a fan out of the suit and replace it on orbit, which is things we didn't expect to be doing, but we did it. And going forward, I know in NEMO and some other analogs, we have looked at AR technologies. You just literally can walk folks, you know, you superimpose that YouTube movie, if you will, over the actual hardware. You can put the pointers and say, now turn that knob to the right and do this to the left, hit this button, wait for an action. So, you know, in some ways, it just simplifies the actions you need to do, right? And so, you know, think of all the systems on a spacecraft that if we're going to go there to stay, not just for a week, but eventually to stay, we will call upon the astronauts to maintain probably a ton of hardware. That's it.
You know, I think this last year of mandatory telework for us here at Johnson Space Center has changed the way I would have answered this question had you asked it a year ago. When I think of augmented reality and the fact that the astronauts are isolated for so long from everybody else on Earth, I think perhaps there's ways to make augmented reality help their emotional health, whether it's, you know, immersive video games or movies or phone calls with their family. I think all of that has some really great opportunities for benefiting from augmented reality.
I love that. I love the use of the having augmented reality as a way to make connections while in isolation. That's a very cool idea. All right, so the next one up is what technical career needs or gaps do you foresee that have to be addressed in order to meet the future technology needs?
One of my other jobs at JSC is working with the university community of practice. And in this team that we have at the center, we work on ways that the center can better engage with universities. And we have targeted universities because that's a place where we have lots of our current JSC teammates coming from. So it helps us get started in really maturing those strategic relationships. And overall, what I hear in those conversations is we need everything. if you have an interest in any kind of a STEAM career, NASA needs you. And there are so many competing places for people to go for a job that there's really no shortness. If you can, like any job you can name, we have it at NASA. We have videographers, we have astronauts, we have engineers, we have safety and quality mission assurance personnel, we have technicians, we have welders, we have seamstresses, we have teachers, we have lawyers, we have doctors of all varieties, EMTs and nurses. I mean, anything you can imagine, NASA needs. And it's the diversity of our team that helps us solve complicated problems. I had a hard time thinking of one way to answer this question. I kept going back to all. We need it all.
I might go from the Stephanie, your excellent, really broad statement to something more specific, only because it seems to often be the answer to a lot of technical problems we have, and that is the material science. Suits, thinking of suits that are pliable and yet strong and can maintain pressure. That's, the other panelists would know better about how far along we are with that. So it's more of a question for all of you, from me as well, is how much more we can do with the material science and in producing our future suits.
No, I'll agree with that one, Tom. You know, if you will, the exterior of the XEMU, you know, as we go forward, I'll say to the average observer, isn't going to look that much different, because we are in some ways applying most of the same materials, and we're fighting mass constraints all the time. Again, we've piled in a ton of technologies, and you just can't bring everything in, you know, at the same time, or else you'll never get something built. And so materials is a good one. And then I was trying to think what's an in-between answer, because I totally agree with Stephanie's and I agree with Tom's. We need help everywhere. I personally haven't noticed a gap per se around, but the one thing, if we've got scientists out there and we've got engineers, is anybody that can cross, you know, sometimes I call it speaking, you know, French and Spanish or French and English around here. You know, the scientists will tell us what that plasma environment's for, and then I still get the engineer who's saying, okay, but what do I do with that? How do I build for that? And we need either really good scientists that know how to bring that data and focus it, whether it's statistically or however, to if you will, a set of guidelines for engineers, or likewise an engineer who's brave enough to go talk to scientists and really try to help them discern down what they're learning about these environments that we're headed towards, and how to turn that into the best way to design a spacesuit or protect us from the environment. You know, we're going to learn a lot, even just going to the polar regions and understanding even the temperature extremes, how that affects us. You know, radiation environments are going to be a little bit different. You know, plasma we're talking about. So we're still learning things. You know, we're going back to the moon, but partly because of the location and partly because I don't think we totally understood it. We're still learning from those environments.
All right. So ultimately, how do you see suit students contributing contributions aiding astronauts' spacewalks capabilities in the future?
Well, I've seen enough to know that I want y'all to come work for NASA. So I'll just say that way. We need super talented people. One of the biggest ways I think you guys are helping us is because, to be honest, you know, when we do get a budget and a mission, we're suddenly under all the typical pressures. You know, it's the triangle we always talk about of cost, schedule, and performance. And immediately we have to get into a mode of down selecting and just moving on to something. And I saw us a few years ago just moving right into technical solutions for displays and some informatics from a hardware perspective. And I felt like there's very few of us, I mean, I was one of them, but there's very few of us saying, well, has anybody done the operator side of this? How would we use these displays? You know, what are we going to, how much do we need to display? How much information is too much? Do we need color displays? Do we really, you know, do we just need to send data? Do we need to send text? And so the information you guys are pulling together and essentially, in some ways, pretty in a high fidelity way, simulating this, you're helping us figure out, or you're just adding to the numbers, especially with your human in the loop testing of what you saw that worked and what you saw that didn't. And I think that's valuable to us today, because again, I'll just admit sometimes we just jump right to the hardware solution without maybe spending enough time figuring out from the operator's point of view what's the right solution first, and then let's go figure out how to technically make that happen. So you guys are right there, giving us that kind of body of evidence to go forward with.
I've been working at NASA for a while, and while I have knowledge about what we've done in the past, I've seen it even in myself in certain areas. We kind of get, well, that's the way we've done things, and how you can help, obviously, many of us here, is coming in with fresh ideas and fresh perspectives. You're not burdened by what we think we can do or what we think is all we can do. You can push us all to say, no, you could do better than this, and this is how. Or why don't you consider something that could be done better? So having people from the outside come in with new ideas is incredibly important to expanding what we can do, both in the suit area and in any area of spaceflight.
And I'll add my own piece to this one. I think it's a really good question and a good thing to think about. You know, even on the presentation screen that we're looking at up here, you see the spacesuit in the background, the ISS spacesuit, and you got the helmet. But then on top of that helmet, you have some helmet lights added on after the fact. And after that, you have some helmet cameras added on after the fact. And even today, there's just more and more hardware that just gets added onto the suit that was designed and built in the 1970s and 80s. That's something our future generations, our exploration spacesuit that I've loved, that it's been taken into consideration is essentially an upgradable platform, where, you know, something that I see is, as we're working with, you know, with suits projects, with various academia and industry, as these emerging technologies really come to the fore and are proven and tested, having a platform that allows us to integrate those so much more easily and efficiently, so that we can get those in the hands or on the suit of an astronaut to make the most use out of as soon as possible, without seeing these, you know, 10, 15, 20-year design loops. It can be a lot more efficient, where, you know, an area of VR and AR is just improving and maturing so rapidly. We want to take advantage of it. And I think this is a great opportunity that shows, even just year to year, how the suits projects have progressed. You can really see the need for that flexible or upgradable suit system to take advantage of it.
Okay, Brian, Alpert, you just touched on a little bit of this next question, but we thought it would be interesting to hear from you guys what emerging technical challenges might we present to future suits participants.
Wow.
So, I mean, I'll give it a go. I'll give it a start. There's a few things that I've always enjoyed thinking about or learning about, whether it's from the suits challenges or others. The first thing that I don't think will shock anyone in the VR and AR world is something that Tom's mentioned a few times here today, and that's really testing out and understanding when an astronaut can and should use voice activation versus when, you know, potentially we could have location-based prompts, or when we really do need, you know, no kidding, switches and dials and stuff like that, or touch screens, right? Understanding the different options there, and even going a little bit further, if we're talking about emerging technologies, for example, is I've, you know, definitely gotten a lot more interested in like haptic feedback. You can almost imagine, right? Tom mentioned the gloves earlier, and the gloves, you know, are one of the biggest challenges in a spacesuit, because you're using your hands so much on a spacewalk that you want to be safe, right? You need the most amount of protection in a glove while still maximizing mobility. Well, what if, you know, using, you know, haptic feedback sensors that are actually underneath the glove, when you pick up a rock or you're trying to feel how a rock is smooth or bumpy or something else, what if there are sensors on the outside of the glove that are connected now to your actual, you know, hand inside the glove, where you're able to get a lot more knowledge and insight through haptic feedback on something like that? Or, you know, if I'm trying to take field notes, and we talked about geology and geologists using field journals, well, what if I have an augmented, you know, virtual keyboard that now I'm out, I would look kind of funny, so don't, you know, get me on my Buzz Aldrin like lunar cam, but what if I'm just sitting here typing in my field notes on a virtual keyboard that, you know, doesn't actually exist, because I'm so used to just taking notes while I'm working? Maybe there's some opportunities there where you kind of hit that really cool intersection of emerging technology and field operations. And that's the kind of area that I think would be really cool to continue, in my opinion, to learn more about. I'm in no way an expert there, but I think that there's a lot of cool things that I would love people to keep thinking about from both the tech side, but also the user side of that, and what it might look like.
Yeah.
The other idea I thought of, sorry, Brian Johnson, just the other idea I thought of for a possible suits would be real-time collaborative training or real-time collaborative operations when the people participating are not co-located. So is that an augmented reality environment hosted in a cloud? Do you have to have, what kind of security do you have to get into it? And can you make all of the connections you need to do in a collaborative 3D augmented reality space?
That's those are fascinating concepts, and I'll take the more physiologic, if you will, the meat part of the system. How do we prepare astronauts physically who are on long duration flights for their work on the lunar surface? I don't feel like we completely understand that. Certainly exercise hardware, it will need to be robust. Certainly being quote unquote in shape in general is important, but what kind of workouts does an astronaut have to do? How do they maintain their forearms and their hands so that they can be fully effective? And how reliable do those need to be? I thought of this when I know there's been work in the past of a suit that actually physically assists the astronaut either through a voice command or through a certain position that can actually lock your fist, for instance, into a hook. So you don't have to, if you're carrying something over a long distance, you don't have to actually be flexing the whole time. That sort of thing. The forearms really get beaten up on a spacewalk, and the shoulders do as well. So some kind of physical assist that a suit can provide might be something that we can consider.
And the only thing I can possibly add to that, all of those ideas, and this is a little out of my realm, but I'm just trying to think out loud here, is on the tools side, you know, getting away from the suit for a second, is, you know, the grading of the rocks. You know, we're not there to pick up as many rocks as we can and bring home, because we just can't do that. You know, we're out there trying to do meaningful science. So if you can grade or assess those samples almost real time, you know, pick up your rock, shoot your magic gun at it. It tells you exactly what it is. It gives you some data on it. You send that data back to the scientists. It either piques their interest or it doesn't. They may just say, put that rock right back. That's a really interesting rock that looked just like the last 3 rocks you picked up. You know, we're good. So I'm pretty sure we're working on some things like that. But you know, but personally, I know for the first mission, we were working on a very simple tool set. I'll just say it that way. You know, if those you know, that magical gun I just talked about, if that was available, we would have seen it because folks have been clamoring to send that on their first flight. So I imagine things like that. Again, we're not there just to collect rocks. We're there to do science, and if we can do as much of that real time and get that data, whether it's passed back to the suit, passed back to the astronaut real time, or back to the ground, I'm sure we're going to need those kind of capabilities.
Okay. How do you think being part of a project team, like a suits team, can help prepare students for their careers? And did you have any comparable projects or research experience as students?
I was in college long enough ago before they had such collaborative teams. And what I've learned being at NASA is that aspect of working in a team, understanding that everyone is good at something, but no one is good at everything. So I hope that these teams have found that, boy, no one person has the answer to everything. And all the ideas can be taken and assessed and evaluated. And that it's really the collaboration and how you work with your teammates that's going to determine in large part the success of what we're trying to do here, but also the success of your team. NASA is all about that, and that would be my first response to that question.
Yeah, Tom, he didn't steal it. That was exactly what I was going to say. It really, you know, we don't say it necessarily every day, but one of the hardest things about doing what we do, most people think at NASA is technology, and it's the people. It's bringing together all these awesome, diverse folks, but then bringing the best of the best together and doing it in an efficient manner to get these projects flown. And you know, we have a lot of smart people, and you know, a lot of smart people in a room can either question themselves, you know, into a hole or go productively forward. And I imagine in these projects, you guys found that, right? You probably had brainstorming sessions and real productive sessions, and then you probably had some sessions that you all went home at night and said, we'll start again tomorrow, right? And that doesn't change. and the thing you got to do going forward here is just realize that you know, it's how to be a leader in those situations, and how to just come forward and not take over. The leader is not necessarily the smartest person in the room or the person with the most power. It's the person who can just really help everybody move forward, and they're not doing it for themselves, they're doing it for the team. You know, again, I always come back to my definition of leader is to serve, right? So if hopefully you folks learned in your group projects that, hey, just helping out everybody else seemed to help you the best. It wasn't the person barking orders that got stuff done. So that's my little sermon.
All right, it looks like we are just about out of time, and we have about 4 minutes left to kind of wrap up and make some final comments. So does anyone on the panel have any final comments for our suits participants today?
Well, I feel like you've had the privilege and the opportunity, and I hope you felt it the entire time of working on an aspect of space flight that many of us on this panel certainly consider to be one of the most exciting aspects of space flight, of human space flight. The human as close to the environment, as close to the vacuum of space and to the surface in which they're working as they can possibly be, and still be in this incredibly dangerous environment. It's exciting. It's a lot of fun. The challenges are huge, and I hope you've felt that kind of excitement as you've been able to work on this. And we can't wait to implement some of your ideas and look to see what you've got.
Yeah, I want to kind of just thank everyone for their participation. And actually, I really want to make sure we take the time to thank the organizers of the NASA Suits project. I think it's so important that we stay engaged and keep asking these hard questions. And like Tom said, these aren't questions that we already have the answers to, right? These are really important questions that we don't have solved yet. So it's really cool to get that feedback, to get these ideas from anywhere we can, whether that's at a university or a startup company or NASA or anywhere in between. I think it's really cool, and you know, I don't pretend to have all the answers. And Brian and Tom, when they're talking about teamwork and things like that, I just think it's cool that opportunities through the microgravity, you know, university, like whether it's NASA Suits or others, just exist so that you can get involved and see all these things that NASA is involved in and working on and thinking about, but also just from our perspective to help us answer questions that we really don't have the answers to yet. I think is really cool. So thank you.
Yeah, I'll just finish with, I really appreciate it, and I can't wait, and nothing against this year, but I can't wait to the day we get to walk into a room full of your cool wares and get to walk around and see everybody demonstrate those. So definitely looking forward to that. I mean, I guess, Brian, I don't know, was it 3 years ago? We were walking around the cafeteria and talking to all the teams. You spent all your time at the University of Michigan table, but nonetheless, talking to all the teams. And just kidding. So the posters were still cool, and I think Brandon is trying to work on, I guess, a part 2, if you will, of this event, and so we can possibly get some of that live interaction going here. So look forward to that.
Yep.
Appreciate it.
We still have some of those team stickers on our desks too. So I remember that. That was great.
Yes, we like stickers too. Yes.
All right, then. I think we are just about out of time. So I just want to thank all the panelists for taking time out of your day to speak with the student, or, you know, kind of voice your answers to these questions that were posed to you kind of in a fired off manner. But we're so happy you were here, and the students are definitely happy to hear all of your responses. And we just thank you for all being here and helping us out with this. So thanks, guys. And we will see the Suits participants later. Bye, guys.